So looking at whether or not the shape is a polygon, concave, convex, keep in mind a polygon can't have curves, it can't have more than 2 sides per vertex meeting, and it can't be open. So sometimes it's better to understand what it's not than what it is. Concave versus convex, anytime there's a dent in, think of like a cave where a bear would live or something like that, that's what our cave is. When we understand the difference between equilateral and equiangular, that's that value about equilaterals, all the sides are the same, equiangular, all the angles are the same, and rhombus and rectangle are just our easy go-to examples of those. A regular shape would be something that is equiangular and equilateral. Lots of kids asking questions about these two formulas here. Hopefully once you see the answers, they make sense to you. Some of the interior angles, remember the Grady triangle, each time he went and got a new side, his interior angles grew fatter and fatter and fatter and fatter. If it's a regular shape and I want to know one of those angles, I'm just going to divide by how many sides I have. As far as exterior angles, that 360 around in a circle, that never changes. So no matter how many sides I have, my exterior angles are always going to add up to 360. If I want to know the measurement of one, all I need to do is divide by n. All right, so looking at A, B, and C for number 1. Any questions when you look at your answers? Olivia?
How do you find C?
So C, I knew it was a hexagon. So because it was a hexagon, I knew 6 minus 2 times 180. So I knew that there were 720 angles or degrees of interior angles. So then that's my 720. I added 12 to each side and I divided. So my x was equal to 122. This that I wrote was 1, 2, 3, 4 x's plus x minus 6 plus x minus 6. Which means I have 1, 2, 3, 4, 5, 6 x's minus 12. That's where that comes from. Okay? Check your answer for 2 and 3 and 4. Anybody want to talk about any of them? So Rachel asks for this next page, what are the D's for? So you know how we've been highlighting about what are the properties, and this D represents the definition. So by definition, a quadrilateral is a polygon with 4 sides. But then all of these are also quadrilaterals. The definition of a parallelogram is both pairs of opposite sides are parallel. So each time that there's a D, that represents, that is the defining characteristic that makes a rectangle, a rhombus, a rhombus. But you have all those other incidentals that are true also. So check your check marks with mine. Once we talk about the definitions, we can look at the properties. And it really is an important conversation about diagonals. Anytime that you have a shape that is equilateral, our diagonals are perpendicular and our angles are bisected. If we have a shape that's equiangular, my diagonals are congruent. I saw a hand.
Exactly one pair of opposite sides is parallel. Isn't the isosceles trapezoid?
Isn't that what I have?
You just don't have it there.
Oh, so I missed, okay, you can put up a Smarty, yay. Let me get that key out and update that. Because, yeah, exactly one set of opposite sides, that is an isosceles trapezoid for sure. I'll buy that. I don't know where my key is. I'll find it. All right, anything else that you see with your eagle eyes? All right. I love these questions here. I think that they really kind of get to the meat of it, like taking a look at those characteristics. And that warm-up we did with the distorted shapes, I feel like really helped us with this, of reading the shapes. Anybody want to talk about any of those? Yeah.
So for the last one, how do you determine that it's a rectangle?
So here's how. If you look at the diagonals, if the diagonals bisect each other, it's a parallelogram. But do you see how all of these are the same length? That means that these diagonals are congruent. So if I have congruent diagonals, I'm looking at a rectangle.
But couldn't it also be a square?
So it could be a square until I see this.
Oh.
Because if this were a square, this would be a 45 degree.
Oh, okay.
Yep, that's a great question.
How do you help with the top middle one?
The rhombus, okay, it's equilateral, so square or rhombus. That's it.
Okay.
So those are my only two that I can choose from. And once I see this 50 degree, it can't be a square for the same reason this couldn't be a rectangle, because those would have to be 45 if they were squares.
How do you find the angle measure?
So see this 50 degrees?
Yep.
That goes for this angle. In a rhombus, the diagonals bisect the angle. So if this is 50, so is angle 1. I know this is a right angle because the diagonals bisect, which means this has to be 40.
Okay.
Because the sum of the angles inside the triangle is 180.
Okay.
Good questions. Keep them coming. What else you got? All right. When we're talking about proving, I took the time to actually write them all out because when I looked at your quizzes, a lot of you did not make sure that you understood that it takes two sets of opposite sides. So if you're doing slope calculations, that's 4 calculations. Because once you take the slope of one set of opposite sides, your choice is either to find the distance of that same side or the slopes of the other two sides. So 2 sets of opposite parallel sides, 2 sets of opposite congruent sides, 2 sets of opposite. So it has to be true for all 4 features. All right, I really want to spend our time talking about these proofs. So graph the given points, done. That's going to be number 1. If you screw up the graphing and you depend on your graphing for either your slope or your idea of what you think the shape is, if you didn't get your xy coordinates right, or if you lost a negative, so when you're this is on the test. So I'm telling you right now everything you need to know. When you're graphing, double, triple check that you went the right direction. X's, Y's, positives, negatives, starting at the origin. Thumbs up if you feel confident graphing an XY ordered pair. Okay,
When we're writing the slope, should we simplify?
always. Okay, so I graph my ordered pairs. I'm like, that looks like a trapezoid. Now my job is to prove it. And I prove it by saying there's exactly one set of parallel sides. Notice I have to do 4 calculations because in order for me to prove it's not a parallelogram, I need one set of sides that are not parallel. So I have to go through and say, hey, check these out, they have the same slope. Do you know what these 3 dots mean? Therefore, right? Or so, yeah, so this is true. So in mathematics, those 3 dots in a triangle are like, therefore, they're congruent. This is your proof. Here's my statement, and there's my justification. I know that the slopes are this. Now, I know that I could have counted on the grid. I need to either see you counting on the grid, I hope you graphed it right, or using the formula. But I need to see that you're doing work because that work is part of your justification. Once you say, hey, the slope is this, and hey, the slope is this, therefore the lines are parallel, I need to see that whole daisy chain of work. Does that make sense to you? So I proved that A and D and C and B are parallel. I proved that A, B, and C, D are not parallel. Therefore, it's a trapezoid because there's exactly one set of sides. I want you to think of that diagram that you had in your warm-up where we had quadrilaterals and then we had parallelograms, kites, and trapezoids. Within a specific trapezoid, you need to go ahead and tell me, okay, is it a trapezoid or is it an isosceles trapezoid? Like, what kind of trapezoid is it? It's not gonna be isosceles because these two distances are not the same. In a perfect world, I would have taken the time to do those distances and said, because the distances are not equal, it's not isosceles. This is the conclusion statement many of you were missing on the quiz. If your job is to prove to me it's this, you have to actually close your conversation. That's like making a sandwich and leaving it on the table. Like, no, you made your sandwich, go eat it, right? You did all this work and tell me what the result is. Therefore, it's trapezoid because it has one set of parallel sides. Take a look at my second example. For this second one, I did this distance, this distance, this distance, this distance. So then I went ahead and said, okay, I know that, therefore this is an equilateral shape. Now in my head, I'm like square or rhombus. So if I can't definitively state what it is, I need to make sure that I do some more math. So I went ahead and I took the slopes of the two sides, and these two sides are not perpendicular because their slopes are opposites but not reciprocals. Therefore, they're not perpendicular, so it's not a square. It's an equilateral shape that doesn't have any right angles on the sides. So therefore, it's a parallelogram, two sets of opposite congruent sides. Therefore, it's a rhombus, equilateral, not a square, because no 90-degree angles. The second way that you might have done this is take a look at the diagonals and said, oh, AC and DB are perpendicular, and I know in a rhombus, but that's not going to rule out it being a square. So you have to think about what calculations can I do, distance, midpoint, slope, really just distance and slope, that's going to weed out what it's not, definitively proving what it is. Does that make sense? Yeah? Questions on the proofs? So your proof must have a therefore statement. You have to have some kind of like wrapping it up. You know, therefore, blah, 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 blah. That's what you want to end up saying. Got it? Okay. So I believe, is that where your key ends or does it keep going? Special parallelogram. Check your answers with mine. Yeah.
So with the rhombus, did you, that's because that, well, since it's split in half, it they're both equal?
Yes, the diagonals bisect the angles.
No, for C.
For C, no, this is a 90-degree angle, so these two things must be complementary.
Oh, okay,
So I have them set up equal to 90 degrees.
okay.
That's a tricky one. Make sure you understand the difference between, with the rhombus, how these two angles are complementary and these two angles are congruent. And with the rectangle, these two sides are congruent. Understanding when you set them equal to each other and when you add them up to either 180 or 90 is going to be critical. Go ahead.
Are we at like 8, 5?
Yeah.
For the first one?
Yeah.
I didn't know how to solve that one. That's kind of.
Okay. So this is a kite.
Yep.
And I know it's a kite because two sets of consecutive congruent angles and the opposite sides of a kite are going to be congruent. So once I know this is 110, so is that. Okay? So now I have these two angles congruent. I look, this is a box, which means it's 90. So I added 110 and 110 and got 120. And then I added 120 plus 90. And what did that give me? 310, which left me 50 degrees left. And this angle's bisected.
Oh, okay.
So that's how I got 25 and 25.
Okay.
So the kite's weird. These angles are congruent. These angles are bisected. These angles are not congruent. These angles are not bisected. So you have to, it's real important that you understand that distinction. And the good news is in a kite, you can sketch it and kind of see it. And one of the tricks that I like to do all the time is whenever I'm not sure, I'm going to draw a super exaggerated version because then I can see that these two are going to be congruent. No way are these. But I can see that these two are bisected and these two are bisected. So when in doubt, sketch a super exaggerated version of the shape and those characteristics will show you. Okay? Any questions on the rest of 8? Go ahead.
For the kite on the right, all the way on the right, how did you get a 45 for angle 1?
Okay. What I did was, oh, I know. That's a right angle. That's isosceles 45, 45.
Oh, okay.
And this is isosceles 53, 53. Yeah. Go ahead.
And then for the next one, I didn't understand how to solve for the weird shape thing. Trapezoid.
The trapezoid?
Yeah.
Okay. So in a trapezoid, these two lines are parallel. So these two angles are always going to be supplementary.
Okay.
So if this is 70, that means that this has to be added to a 70 to equal 180, so that's got to be 110. Because it's isosceles, my base angles are going to be congruent.
Oh, okay. No, I should have known that. Okay.
There you go. Go ahead.
Why don't you have enough information for the last one? Because did you say that she was given 74?
Yeah, I don't know that because I don't know if it's isosceles. Nobody told me that.
Okay.
So unless you tell me it's isosceles, it looks isosceles. I'd like to think it's isosceles, but I don't think I have enough information to solve for that.
Okay.
Are we good? Yeah? All right. How are we on 9? Any questions on that? All right. So this last one, this last side, the formulas for our shapes, they all come back to base times height. If you can remember base times height, you can remember triangles are half of rectangles. You can remember parallelograms or just like imagine your mom saying, sit up straight. So you have that base times the height. Your trapezoids, half of the height times the sum of the bases. And your kites and rhombuses are then going to be half the product of the diagonals. Think about gift wrapping your shape for your best friend. And then there's a little mid-segment conversation. And then we have a couple area problems. All right, and then you don't have this key, but you had the answers. Anything that you figured out that you did that you want to talk about and go over? Go ahead.
For the first one, number 4 is a quadrilateral or a polygon.
So determine whether the figure is a polygon. This is the easy one. Yes, no, yes.
Oh,
Because of that, right?
Yeah.
So we're gonna say that, maybe like this shape is a polygon, but if you're including this whole line, then, yeah. Anything else you wanna talk about? That you weren't able to go through?
sorry, can you explain this sometimes always another?
Sure. So decide if you have enough information, that one, or, is that the sometimes? No, here you go. A rhombus is sometimes a square. A square is always a rhombus. See the difference?
Yeah.
Okay, a rectangle is always a parallelogram. A parallelogram is sometimes a rectangle. You okay with me reading it forwards and backwards?
Yeah.
Okay, trapezoid is sometimes isosceles. An isosceles trapezoid is always a trapezoid. So this is a special kind of that. This is a special kind of that. This is a special kind of that. Okay, a parallelogram is a rectangle sometimes, but a rectangle is always a parallelogram.
Okay.
So think about what is the special kind. Think about when I picked up Christopher from preschool and he was mad because his teacher told him that we lived in a place other than, and getting Herndon and Virginia in his head, right? He heard me say we live in Herndon, his teacher's like, we live in Virginia. He's like, nuh-uh. Everybody in Herndon lives in Virginia, not everybody in Virginia lives in Herndon.
Okay.
Okay? Anything else as you scroll through? And you checked your answers?
What should we route to?
Unless it says so, always the nearest hundred. If you are working and you have questions, you can feel free to ask.
How did you do number 28?
Number 28. Okay, it's an equilateral triangle. So I drew that, right? So if I have, that gives me a 30, 60, 90 triangle. So that this base here is half of 13, and this height here is 13 halves root 3. So it's 1/2 of the base times the height.
I forgot how to like go on from there. I don't know. 'Cause you're thinking-
For what you enter into your calculator?
Yeah.
So my area of a triangle is equal to 1/2 base times height. So my area is equal to 1/2. My base is 13, and my height is 13 times the square root of 3 divided by 2. So your calculator, that I would enter all these into the calculator.
Okay.
So, you know, sometimes entering things in one at a time makes sense to me. So I gotta tell you the truth. If I were here, I would do 13 divided by 2, and then I'd hit enter. And then I would multiply that answer by 13, and then I'd hit enter. And then I'd multiply that answer by the square root of 3, and then I'd hit enter. And then I would go ahead and I would divide that answer by 2, and then that would be my answer. So a lot of times with the calculator, I'll break my calculations up, because I'm terrified that the calculator's gonna do the order of operations different from me. All right, clear it down. When you come back, there'll be a test on it. Oh, I lied. Review packets in the inbox, and then you go to, let's say keys back in the basket.